Hi everyone. Welcome to another meeting. Welcome to another meeting at ChemSoc. I'm Natisha, president, as you know. As for right now, I'm actually waiting on Tiffany to arrive at the lab. Today we'll be doing some yogurt making, so hopefully we can get the process done as fast as possible. Which is gonna be delayed because Tiffany is not here as yet, but she should be on her way. Also, I'm going to show you guys what the wine is looking like now. So we had three wines. We had the pineapple, we had banana, and we had apple banana. So as you can see, we have the apple banana and banana ones remaining. This one seems like it's still fermented. This one looks pretty much finished. The third one, the pineapple, oh look who's here. The third one, the pineapple, there was a lot of acid in it. I'm guessing because we blend it instead of just cutting it up. So the acid from the pineapple kinda spoils it. So we have these two left. So we're going to siphon them. We already did the primary fermentation. So we had already siphoned them once before, so we're going to siphon again. And siphon is essentially using this tube to transfer the liquid into another bottle or another flask. Um, yeah, so that's what we're going to do today. And yeah, I forgot what I was going to say a while ago. Did I say something else? I forgot. Let me turn on the hot plate. So while we're boiling the milk for the yogurt, we can siphon the wine. All right, so I'll be using this pot here today. I'm going to add the milk to it and hopefully in a boil over. Let's go. So this is the milk we're using. Miracle or whatever. I should measure it down. I probably should. And I left my measuring. Wow. Wow. This is 1 liter, right? So we're going to add the milk to the pot, trying to figure out how much we want to add. Based on the size of the pot and also how much starter we have, how much yeast starter we have. These actually look like they're still going in. But I'm gonna sip on it. 4 cups. Normally I ask how much something there. Oh, oh no, yeah. 1 liter is how many cups? We don't do it that on the one to two. It's such a shame I can't put the measuring cylinder. I left my measuring cup 6 ounce. See, I don't work with the measurement there now. I work with milliliters and them things there. 6 ounce? What you want ounce now? Ounces and these things are for people who cook, not for chemists. This was like half. It feels like just plenty. Yeah, it feels like half. We're estimating, guys. So we're going to boil the milk, and then after we boil it, then we cool it, which I would love to have some ice for, or we can put in some water and make it cool too. All right. So while we're boiling the milk, and we're going to siphon these in a minute, but let's look at some of the theory for yogurt making, and then we'll get back to the stove. Oh, nice. All right, so yogurt is an ancient food that has been around for several millennia, as we should know, and it is believed to come from the Turkish word, and I'm going to assume it's pronounced yogurmak, which means to thicken, coagulate, or curd. So in today, the FDA defines yogurt as a milk product that is formed or fermented by bacterial strains. Um, a lactic acid produced in bacteria, Lactobacillus bulgaricus, and Streptococcus thermophilus. So those are the main bacteria that are used in yogurt production. You may see other lactobacillus species or subspecies like Lactobacillus acidophilus being used, but these two are the main ones that are used. The yogurt, as said before, is produced by bacterial fermentation. So we looked at fermentation before, but we had looked at fermentation of sugars in fruit to make wine by yeast. And then now we're looking at bacterial fermentation in milk to make yogurt. So the bacteria that is used to make yogurt, they are known as yogurt cultures, and the fermentation of the sugars in the milk by these bacteria produce lactic acid, which I'm sure we're all familiar with. So your lactic acid acts on your milk protein to give yogurt its texture as well as the flavor. So it has a slight tart, I guess you can say, flavor. Those are for the people who eat yogurt. For if you don't, I don't. It's easy to get that checked out. I don't know. Cow's milk is the milk that is mostly used to make yogurt. It's most available, at least. And the milk can be used also from water buffalo, goats, ewes, mares, camels, and yaks to make the yogurt. So similarly to how you have different types of milk, and you may have like different types of cheeses, using different types of milk. It's a similar thing with yogurt where you can use different types of milk for your yogurt making. So that is going to affect, of course, how your yogurt comes out specifically. The milk used can be homogenized or not, and sometimes it's pasteurized, sometimes it's raw, especially if persons are doing it at home and you have maybe persons who have them cold can milk it and can actually make the yogurt at home and everything. And usually that milk has in bacteria already when it's raw, which is why it spoils very easily. So I guess the process is quicker that way. But each type of milk produces a different result. Whether you use raw pasteurized milk, homogenized milk, or if it's not homogenized, and the source from which you get your milk, what animal you're using it from. Nowadays, I think that they're now using vegan stuff. I think call them like plant sources, etc. for milk. So then the yogurt is different. So the benefits of yogurt. Yogurt may provide potential health benefits by enhancing nutrient absorption and digestion. So it helps to improve or maintain good um, gut health or in your intestines. Because it contains live cultures, it is often associated with probiotics. And remember, we said that cultures refer to the microorganisms, the bacteria in the yolk. So, probiotics we know has positive effects on your metabolic health, which, as we alluded to before, includes nutrient absorption and digestion. It has positive effects on your immune system and your cardiovascular system, and hence consuming yogurt helps those systems in your body. There are a number of nutritional advantages of yogurt. Um, it is high in calcium. Well, let me not say high. It has calcium in it by virtue of being made from milk. So the mineral calcium, or the element, I should say, it helps to build stronger bones and teeth. Probably know that from basic school. It also has, sorry guys, the milk almost boiled over. It also has the ability to help build and repair muscles and sorry, bit of pay attention to this store. And it is essential for body functioning as it provides vitamins and minerals. For example, calcium, as we mentioned. It has conjugated linoleic acid, which stimulates immune system and which stimulates the immune system and has anti-carcinogenic properties. We also talked about it having live cultures or live bacteria, and these bacteria can help to improve digestion, especially of lactose that is contained in yogurt. So those are some nutritional advantages of yogurt consumption. So all of you guys who are not lactose intolerant, but don't consume yogurt, need to get that checked out. That's not normal. So the composition of yogurt. Plain yogurt, if we use whole milk and milk from the cow to make the plain yogurt, it typically has 81% water, 9% protein, 5% fat, and 4% carbohydrates, which is essentially sugar. Um, you, as you can see, most of it is water, which is why it's so good for you. It has so much water in it, and water is good for you. And 9% protein, 5% fat, 4% carbohydrates. So the macromolecules or the macronutrients, protein, it has mostly protein in it, followed by fat and carbs. If we have a 100-gram amount of this plain yogurt made from whole milk, it provides 406 kilojoules or 97 kilocalories of dietary energy for your body. Um, and if we are to look at its contribution to your daily value intake of nutrients, that is, it supplies 31% of what your daily intake of vitamin B12 should be, and 23% riboflavin. It also, as we know, supplies minerals like your phosphorus and selenium, 14 to 19%, and we already know that it supplies protein, 9%. So let me just look at the plain yogurt that I have. If I can read this language, because is it Spanish? I think it's Spanish. Why some molecular language Spanish? I'm looking, guys. It's Ellen Bear and Ellen Bear is what French or something. I think that them just have a bag of stuff on it. That them don't know them selling to an English market. Alright, so this is a how much grams is this? Lord, this is a challenge. This is 125 grams. This plain yogurt that I have, 125 grams. I doubt you will be able to see it, but I will show it regardless. There we go, 125 grams. And it has, well, it gives you 66 kilocalories as opposed to the 97 that was on the presentation. So 277 kilojoules, 66 kilocalories. That's 31 calories less than what was stated. But I think this one they use cow milk cream. If you can see, can you? It's very blurry, and the writing is very fine. But anyway, they use cow milk cream, but they also use skimmed cow's milk. So doesn't seem like they use entirely whole milk. So that might be the reason why it has less kilocalories. I'm trying to find the micronutrients on it, but Lord, the struggle to read this thing is real. It's a whole lot of foreign language. But anyway, guys, moving on. I just wanted to see if what I actually had from what I bought matched up to the theory. All right, so that's the composition of yogurt. It said 81% water, 9% protein, 5% fat, 4% carbs, which is sugar, and we highlighted that it was a rich source of vitamin B12 and riboflavin, 31 and 23% respectively. All right, so the yogurt making process is, well, it can be divided into 3 steps. So to make the yogurt, first we're going to heat the milk. We heat it to about 180 degrees Fahrenheit. I don't remember how much that is in Celsius, honestly. But we heat it for about 30 minutes. And we do that to denature the whey proteins that are in the milk. So when you denature these whey proteins, it allows the proteins to form a more stable gel or to coagulate together or to get thick. So basically, it's almost like the proteins are precipitated out of the solution. So your yogurt is pasteurized before you add any cultures, and this pasteurization process kills any pathogens that can spoil the milk and eliminates potential complexes for the active cultures. So as I mentioned before, if you're using raw milk, it already has bacteria. So which is why raw milk versus the milk that you buy at the supermarket, the one at the supermarket lasts a lot longer because it has been pasteurized. And for most milk, they also do carry out a process called homogenization. So um, first you're going to heat, as we said, with pasteurization, you want to kill microbes that are already present so that when you add the microorganisms to active culture that you want to it, then it will carry out the fermentation as a result of those cultures and not due to microorganisms that were already present. Because essentially they're going to spoil it if you don't get rid of it. You know, really nice to drink it. So warm. All right, so the next step of the process is cooling. So after you pasteurize the milk, we said for 30 minutes, on average, you're going to cool it down to 108 degrees Celsius. And Lord knows I don't know how much Celsius that is. 108 degrees Fahrenheit. And that is the temperature for optimal growth of the yogurt starter cultures. Right? So you don't want it too hot because what's going to happen if it's too hot? The cultures are going to die. You want it cool enough to where it encourages some optimal growth of the starter culture. You don't want it cold to where the microbes can carry out fermentation because the temperature is too low. You want it just right, basically, like Lolila. Commercially, they may use a cooling tank to do the cooling because, well, the cooling tank, you can essentially set it to the temperature that you want and it just cool it to that temperature and maintain that temperature. So you don't have to worry about it cool it and it get too cold, you have to put it back again. The cooling stuff does all that work for you. But if you're making it at home, then you're going to have to use a thermometer or use your conscience or something to know when it's too hot. So the third step and the main step, this is where all of what happens. This is where your yogurt starter cultures, also called probiotics, these are added to the cold milk, and you incubate it until a pH of below 5 is obtained. And sometimes you really don't know when that is. If you're at home, you literally can just taste it. It's going to taste tiny. If it start becoming acid with the lactic acid, it's just going to taste tiny. So when the pH drops below 5, what happens is that the micelles of casein, if you don't know what micelles are, well, let me try to give you an explanation. It's somewhat of a kind of a droplet or a group of casein protein. So casein is the main milk protein in milk, and if you have the proteins basically grouping into bunches. So a micelle is usually formed with fat droplets. So if I drop some fat in water, the droplets of oil or fat or liquid are going to cling to each other. So let's say I shake up the bottle with water and fat, you're going to end up with micelles of oil. So basically, the hydrophobic parts of the molecule turn inward towards each other, and then the hydrophilic parts outwards towards the aqueous environment. So you end up with clumps or groups of these molecules together. So the micelles of the casein, and these are amphiphilic proteins, they are going to end up losing their tertiary structure. But remember, we are having lactic acid being produced in solution, which means you are lowering the pH of the solution. And we know that proteins are specific, when they are functioning, they are specific to a certain pH. So if they are in an acidic environment, you find that they become protonated, or the amino acid residues become protonated, and they lose their tertiary structure. The intermolecular interactions result denatured casein proteins reassemble by interacting with other casein proteins, and these intermolecular reactions result in a network of molecules that provide the texture of yogurt, which is kind of semi-solid. It's not hard solid, but it's also not very, it's also not very liquid. So basically, just going through that again, you add your yogurt starter, which contains your microorganisms. You add them to your milk, and that is your pasteurized, cooled pasteurized milk. And when you add it, you find that the casein, which you should know about primary, secondary, tertiary structure of protein and the bonds that are involved in that, and hydrogen bonds are involved in creating tertiary structures of protein. So when your lactic acid is being produced now, it results in the protonation. In the protonation of the amino acid residues, and when protonated, it loses its tertiary structure. When protonated, it loses its tertiary structure, and then all of these Okay, that's it. All of these denatured casein proteins are going to interact with each other, resulting in that network you see in the yogurt. So it's almost like once the proteins become um, denatured, they kind of separate from the liquid part of the milk, forming that semi-solid. So those are the three steps of the yogurt making process: pasteurization, cooling, and fermentation. So now we're still on heating. All right, so we have heated for approximately 30 minutes, 305. So we're going to take off the milk to let it cool. So let me show you guys where we're at now. We're going to cool it, cool the milk. Why is my camera blurry? Can you act right, please? Why did I do this? Oh, here we go. All right, so we're going to remove the milk from the hot plate and we're going to cool it. Obviously, I said I was going to cool it in that water over there, and now I'm cool it up too much. Anyway, we're going to cool it in the water because we don't have any ice, so just for it to cool fast, we're going to put it in that water bath. That's what we're gonna call it. And then in the meantime, we're going to siphon these into new containers. So initially, when we did the primary fermentation and we siphoned them, some of the yeast got into this and the fermentation continued. This one looked like it's still going, but I'm gonna siphon it either way and at least get rid of some of the sedimentation. This one looks pretty nice. So I'm going to siphon it into new bottles or jugs, and then let's see. I don't know if I should leave this for longer. We'll taste it and see. When we taste it, we'll find out. So hmm, there's one smaller container. I don't see anything smaller. I guess we're gonna have to use this. Alright. Now put this first. Alright, so I'm going to put the milk in there. We'll put it. I'm gonna there's a straw. Huh? Alright, folks. So we're going to siphon this way. I'm going to put this. I'm going to take off this and put it up here without trying to disturb it too much. Jeez. Chaw, chaw, chaw. Alright. Alright. Hold it. Alright guys, so I washed out a new bottle to do the siphon and I put the bottle that we're going to siphon out of up there. So now I have to put some ethanol on my hands and I have to wash this tube with some ethanol and then fill it up with water. So that's what we're gonna do now. I'm trying to put the camera to where you guys can see. Not at all. But alright, so I'm going to ethanol And I use ethanol so that it can kill the microbes so that it doesn't get into the wine. And then I have to pour ethanol down the tube. Tomato, it was in the other. One second. For the and then after fill this up with this water. No, no ethanol in that. Oh well. Ah. Then one in I'm trying not to put it down in the bottom because I don't want it. Hello. Oh, you go out. You go out.
Smell better?
This one.
It was a cooking mix, you know. They did wipe off the thing, the food, the brick.
Nothing. What?
Brick. If it go above water, above the liquid, brick, you have to cook it again.
Oh God.
Not a heat that can reach the bench of right. Cook it some more. Some of the liquid is about all I know come up because if you push it under the bottom, it'll start full of all of it. And we're trying to find stuff. Well, that's the key.
So, you know, so the alcohol. So, alcohol. This one. You know, so it. Oh. I want to know this one. All right, guys, we're kind of busy. Trying to sit on the wine, which is why you guys are not seeing because it's only two of us. Which I trust that you did see the first part of it and how exactly we carry out the process. That's just what everything is. Yeah. Jesus Christ. On. Okay. Yeah.
Yeah.
Stop.
Let's try.
We check the milk. I know. Oh, there's not somebody calling me.
Amen.
Oh,
Okay, so we finally got that one done.
finally,
It's not more
sorry that you guys couldn't see everything. Kind of short.
Star.
Here, have one down. Is it clear?
Yeah,
Have it-
it's strange.
have it come again. Alright.
Oh, it's just a little thing. That makes sense. So the milk is cooling.
I was first and the alcohol.
Oh, I'm not sure.
Alright, so we're going to check the temperature of the milk in Fahrenheit, of course. Let's look at it. And see if it's cool enough.
It's a bit more.
It's cool enough. Feel like it's cool enough still. Probably too cool.
How much it is?
89.
Fahrenheit?
Yeah. Yeah. It's too cool. I just heat it. Let's see he won't get it.
Yeah, this one is like to get to the icon.
Alright. So the milk is a bit too cool, so we're going to heat it back up that it can get to about 110 Fahrenheit. In the meantime, we're going to have to put on the other one, the banana. Let's see. Let's see.
You want to do this? You want to do this?
It is. Ah, it can please make our where's the cup? Yup. Oh Jesus. Ah, the stress out. Stress out. Who are you asking these things? All right, so fun number two. So when you pull up something there. All right, so fun number two. Jesus. All right, so we're going to do the second support, guys. Um,
Yeah, but then it also tastes like it no feel drink. Yeah.
I was afraid. Here we are. All right. That's very good. All right, so we're going to do this one number two. So we rinse it with ethanol and then this one. All right, guys. So again, we're short staffed, so it's hard for you guys to see everything when we're all occupied. Don't know why my camera is acting so lazy today. When my hands are. All right, so we did the Stefan one wine already, and we're going to do the second one. This is the banana wine. This one, the last time I tasted it was really sweet. That one never sweet. So let's hope. Oh, that messy. All right.
Alright, look at this so because this no come on.
Feel like it's gonna have the same vibe as the next one.
You know, make it.
No man, no man,
You know what? 5 minutes to see.
no man. This better than it tastes sweet.
Oh, it is sweet. This is the rum turn up.
The one in the taste as bad.
Okay. Well, I mean, 1 out of 3. It's not so bad.
That bread.
Let's check the temperature of this thing.
Although it kind of tastes. Let me check the temperature of this thing. We're at about 100 and something. Here. Reviews. Mm, it is of alcohol. It's sweet, but it also, I think, like it stay a little bit too long. Touched. Ah, it don't taste as bad as the next one though. I thought, when I tasted that one last week, I think that one I got shot more than this one because this one did just taste like juice last week. It just tastes like really sweet banana juice, if that makes sense. This is this is show me talk to my drink. Yeah, that's what my cock. Alright, this looks it's at 109, so I guess you can work with that. Let's take it off the stove. She said 1 teaspoon to 6 ounce. How much ounce? Whatever. 1 ounce. Do you want a teaspoon somewhere? No, as in how much ounce make a cup. What ounce? Because we use pepper and then pepper. Let's see. This was this was 2 cups. Like 1, 2, 3 the ounces. 1, 2. I put it in next to it. Okay. You know what I mean? Guys, we're doing some calculations. 8, 8 ounces, and this is okay. 1 tablespoon. Okay, so we have to convert that again. So we're using this, guys, and we're supposed to add 1 teaspoon for 6 fluid ounces. So we use 2 cups, which the 2 cups is this is 16. Yeah, 250. So we use 500, which is 2 cups, and then 2 cups would be 16 fluid ounces, right? And it's 1 teaspoon is 6 fluid ounces. It's about 3 teaspoons to 16 ounces. I mean, 6 trees are 80, now we have 16 ounces. So 3 teaspoons. And we have a tablespoon. So now we have to convert 3 teaspoons into tablespoons. Oh God. Oh, how much teaspoon make a tablespoon? First, because we're not used to this, we're used to milliliter and liter and cm and those things.
Yeah.
One
What we have
teaspoon. No, the next way. 1 tablespoon. 3. All right, so one of these then. To the 3 teaspoon. All right, we're finally finished the calculation. So we're using one of these. Mighty God. Whew, that harder than most. So this is the plain unsweetened yogurt that basically tastes like nothing for the probiotics. So we're going to use 1 tablespoon. Take go. Stir it in. Incubate. How long to incubate? Huh? About bottles. We thought we'd be cooking in a lab. Alright, so that is mixed in. You know much? I did not buy about 3. That's what I use to make some yogurt because I can't make the money waste. Crazy. At the time, I just couldn't convert in my head the whole teaspoon thing, and let's say, you know what, 3 must more than enough. So let's just do that. Let me transfer it to a bottle now. All right, guys. So while we're transferring the milk to a bottle, let's go back to the theory. I think we don't have a lot of theory. Yeah. Or open. No, it's open. That open with it. Something in there. Almost 1 or 5 10 hours. What? What I'm going to have to do, probably have to go do this again and carry some free. All right, people. Oh. So let's finish up the theory. Yeah, of course, questions. So, oh, we can do our next one. We can do our next one. I mean, the milk can last the next week. And then we can sweeten them and then bring them. We can put Imagine. That Alright, so the yogurt product, the qualities of your final yogurt product. For example, the thickness, the tanginess, the sweetness is dependent on a number of factors. And that includes the type of milk that you use. We already discussed type of milk and how that is, the amount of yogurt cultures, that is your ratio of milk to culture that you're using, the level of pasteurization. So even though we heated it and everything, there are actually levels of pasteurization. You have different levels based on what you're pasteurizing, and the pasteurization levels are depending on the temperatures that are used. The time for your fermentation. So the incubation that you do after you add your probiotics or your live cultures, the incubation is going to be where your fermentation takes place. You have some persons that strain yogurt, and then the characteristic yogurt, of course, is going to be dependent on the flavors or sweeteners that you add, the fruits or jam that are used. So all of these factors play a part in the final product of yogurt that you get. So how do we make this yogurt? First, we start by cleaning and sterilizing our equipment, because remember that we're using microbes and we don't want unwanted microbes to compete with the cultures that we're using. So you want to clean and sterilize your equipment and tools. And then you are going to heat your milk to at least 180 degrees Fahrenheit, stirring occasionally to prevent the skin from forming. And also making sure that the milk doesn't boil over or scald. Once that is done, you would boil it for about 30 minutes. Once that is done, you are going to cool to a range of 110 to 115 degrees Celsius. And of course, you can use an ice bath if you need to, or stir the milk occasionally if you need to, just so that the temperature will drop really quickly. And then the next step, of course, you're going to add your starter yogurt. So the yogurt that I showed you guys a while ago, the plain unsweetened yogurt, it has live cultures in it, and it's also not pasteurized. You can use that as your yogurt starter. So if you're using pre-prepared starter, you would mix at step 4, you would mix your starter into your yogurt. So you combine about 1 cup of your warm milk with the yogurt and you stir it. And you want to add this yogurt milk mixture to all of the warm milk that you have. So essentially you want to stir in your yogurt culture until everything is nice and combined. If you're using powdered yogurt culture, of course you'd have to follow the manufacturer's instructions to prepare it and add it to the specified amount of warm milk. And it is important that you homogenize the mixture, meaning you mix it so that everything is nice and incorporated and you get a homogeneous mixture. Once you do that, you want to pour it into a container. You have yogurt makers at people buy online or so. They're kind of like an incubator where you incubate the yogurt in it. And you can also use a thermos or anything like that to incubate it. So you incubate it between 110 and 115 degrees for 5 to 10 hours. And depending on the desired flavor and consistency that you want, longer or shorter incubation periods may be used. So if you want it really thick, it may be left for longer. Also, left for longer if you want it to have a more tart taste. So of course you don't disturb it during incubation. Just leave it at that temperature so that the fermentation can take place. So after incubating is the good part. You're going to refrigerate your yogurt for 2 to 3 hours. You can add any flavorings. So you can add sweeteners or jelly, jam, whatever you're adding. You can add fruits to it, whatever sweetener you're adding to it. And of course, you would store this in your refrigerator in a sealed container with a glass plastic thermos, and that can store for up to 2 weeks. But of course, you know that the longer you store it, the flavor of the product is going to deteriorate over time. So that's pretty much it, and it's a pretty easy thing that you can do at home. Literally, boiling milk, you get the plain yogurt with the probiotics added to it, added to the cold milk. You incubate it, afterwards you sweeten it, add fruits, whatever, and you're good to go. Very easy, right? So that's something you can try at home, and of course we would upload the procedure so that you guys can have it and you can run your own experiments at home and enjoy your own yogurt. So now that we're done with the process itself, this is just a diagram, a schematic of what the process is. So of course, first you collect your milk, whatever source that you're using. So if you're using cattle, if you're using goat milk, whatever milk that you're using, you collect it, and you would stabilize your milk. There is usually heat treatment or pasteurization that happens in that process, because if you just store it like that, it may just spoil because of the microbes. Then you carry out your fermentation, cool it, mix it, pasteurize again. So for some companies, after they have made the product, they carry out heat treatment and then they package it and carry out quality control. That's pretty much the process in a nutshell, synopsis. The home process, of course, is way simpler, and a lot of persons carry out this at home. So, of course, after every experiment, you must know what you have learned from all of this. So, it is question time, of course. Let me get a pen to record the scores. I don't have the scores from last week, but you will have them. All right, then. So let's start with question one. Let's start with our first question, say the 24th of December, 2025. the first question is, all of the following are nutritional advantages of yogurt consumption except they have improved digestion and gut flora, helps with cell repair, building stronger bones and teeth, stimulation of immune system. All of the following are nutritional advantages of yogurt consumption except improves digestion and gut flora, helps with cell repair, builds stronger bones and teeth, stimulation of immune system. Which is the answer? I'm seeing A as an answer, and she changed her mind and said B. I am seeing D as an answer. Any other answers? Any other answers? Are there any other answers? You're also free to change your answer to do so. All right, so the correct answer comes from Ciandre. So the correct answer is indeed helps with cell repair. So we did talk about it improving digestion and gut flora because of the microorganisms that are in the because of the microorganisms that are in the yogurt. So Ciandre would have been the first person to get that correct. We also talked about it having calcium, being a source of the element calcium, which we know is also found in milk. And we also talked about stimulation of the immune system because of the probiotics. So some persons weren't paying attention. So on to question 2, as 1 point for Ciandre. What sugars in milk can bacteria possibly ferment to produce lactic acid? Remember, we're not talking about alcoholic fermentation. Now we're talking about lactic acid fermentation. What sugars in milk can bacteria possibly ferment to produce lactic acid? It's 3 points. So that should tell you need to tell me 3 sugars, not 1. You can name 1 and get 3 points. You name 1, you get 1 point. That's crazy. You must name
just a little PSA. That
3
staph bacteria.
3 sugars in milk. Waiting for the answer. I am seeing some other 1-word answers. I am seeing a 2-word answer. You can't get 3 points for 1 word or 2 words. Three sugars. Any other answers? Seeing lactose, glucose, and sucrose. Sucrose is not the one that I'm looking for. I'm sorry. Sucrose is not very high concentration in milk. Doesn't have a high concentration in milk anyway. Let's see the answer. Andre says lactose, Cheyenne says lactose, Brian says lactose, sucrose, Cheyenne says glucose, um, Cheyenne says okay. I guess Cheyenne gets the point. It's galactose. Guys, remember that bacteria ferment simple sugars into your lactic acid. So it doesn't directly go from lactic acid to from lactose to lactic acid. Boom, just like that. You have to break down your lactose, which we know or we should know is a non-reducing sugar, and it is a disaccharide composed of two monosaccharides. And those two monosaccharides are what? Glucose and galactose. So it can break down your lactose, glucose, and galactose. So Cheyenne gets those 3 points, I should say, not 1 point. All right, so to the next question. It is to name two main bacteria species used in yogurt making. So what are the two main bacteria species used in yogurt making? And I specify saying species and not the genus. You must give me the species. Lactobacillus bulgaricus and Streptococcus thermophile. Any other answers? Guys, you must give me the species. You can't just give me the genus. Any other answers? Andre, please review that answer. The answer needs some revision. Any other answers? So I'm guessing nobody gets the 2 points. Nobody gets the 2 points. Lactobacillus delbrueckii, Streptococcus thermophilus. That sounds like a Googled answer. That sounds like a Googled answer. I don't recall mentioning one of those microbes. The two main can use several species of lactobacillus. But the two main bacterial species that are used are, I'm guessing that nobody wants the 2 points, so I'm going to give Andre 1 point for lactobacillus vulgaricus, and I'm going to give Natural Wonders. I'm not sure what your name is. It would be great if I had a name. I'm going to give them the other points. Is it?
I don't know.
Man, I don't know what to say. All right, so next question, guys. Oh, Jodian. Jodian. Stop this, please. Jodian. Cheyenne, me didn't even ask the question yet. Mighty God, let me ask the question now. Reassembled denatured casein proteins are known as. All right, you can answer now. Reassembled casein proteins are known as. Are they known as whey? Are they known as micelle? Are they known as curd? Are they known as yogurt? I like that question, you're bad. Reassembled denatured casein proteins are known as. What are they known as? I'm seeing several different answers. Huh? Are those your final answers, guys? Are you sure those answers are correct? Um, so the correct answer is C. And Miguel got that correct. And I'm sure you're all wondering how come it's C. Well, remember that we said when the lactic acid is produced, the protons from the lactic acid do what? They protonate the amino acid residues of the casein, which is the main milk protein. So when it protonates those amino acid residues, the tertiary structure of the protein disintegrates and the protein becomes denatured. And then the parts of the denatured proteins are going to combine with each other. And that is what is going to form your curds. The whey is the liquid part of it. The micelles were basically the initial state of the casein protein. That's how they were before they were denatured. I'm gonna repeat that part so many times because I really wanted you to get this question. But Miguel gets that point. So on to our next question. True or false? 80% of plain yogurt made from whole milk is water. True or false? 80% of plain yogurt made from whole milk is water. Is that true or is that false? Is that true or is that false? Is that true or false? Okay, I'm seeing some answers. I wonder why Sandra changed him answer. Interesting. 80% of plain yogurt made from whole milk is water. Is that a true statement or that's completely false? That's a sham. So I'm guessing these are everyone's answers. The correct answer is false. And Andre was the first person to get that correct by virtue of changing his answer. So it is false. 81% of plain yogurt is made from whole milk is water, not 8%, 81%. That was a trick question, and yes, I intentionally put the false before the true. Maybe that catch the Andre, probably. So yes, it's a trick. Nothing is wrong with that. That's why you have to read questions properly. All right, so next question. Question 6. Which factor does not directly affect yogurt product? Which factor does not directly affect yogurt product? Is it the incubation time? Is it the homogenization of the milk? Is it the starter culture quantity? Or is it the type of milk? Which factor does not directly affect yogurt products? Is it how long you incubate it? Is it whether or not the milk is homogenized? Is it the amount of culture, starter culture that you use? Or is it the type of milk that is used? Okay, I'm seeing some answers. There's a popular answer I'm seeing. All right, so correct answer is the homogenization of the milk. Which most companies, they homogenize their yogurt. They can homogenize the milk when they're processing it. Not always, but the yogurt for sure they homogenize. But the homogenization of the milk does not directly affect the yogurt product. If you're producing milk, then it will affect it. So the correct answer comes from Julianne, first person to give the correct answer. So they get that point. Let's go to question 7. What percentage daily value of vitamin B12 does plain yogurt from whole milk supply? What percentage of your daily value of vitamin B12 does plain yogurt from whole milk supply? Is it 14%? Is it 23%? Is it 19%? Is it 31%? What's the answer? Seeing some answers coming in. See Andrea and Jolien both say D. And Miguel says B. What says everybody else? No other answers, I'm guessing. So the correct answer is D. And that first correct answer came from Ciandre. So it is 31%. 23, I think, was for riboflavin. And the 14 to 19 was for the minerals. No, you came in just a second late. Yeah. The Ciandre was the one who got it first. So for the next question, question 8 out of 12, what is meant by amphiphilic protein? What is meant by amphiphilic protein? And I'm gonna go Google it. What is meant by amphiphilic proteins? The first part of the word should tell you everything you need to know. Yeah. Having both hydrophobic and hydrophilic region. Is that it really? Any other answers? No other answers? Okay, so amphiphilic proteins are proteins with both hydrophobic and hydrophilic regions. So Ciandre is definitely Ciandre is correct. That answer is so good, Mikhail. Ah, that's such a Google answer. So on to our next question. We should be at question 9, I think. What is the term used for the denaturation of casein proteins and separation of milk? What is the term used for the denaturation of the casein proteins and the separation of the milk? What is the term? What you know? What is the term used for the denaturation of casein protein and the separation of milk? Y'all are falling for the trap again. Okay. Let's see the answers. Let's see the answers. What is the term used for the denaturation of casein proteins and the separation of milk? Is it agglutination of the protein? Is it coagulation? Is it curdling? Or is it thickening? Are those the final answers? Mikhail just all over the place. Make up your mind. Make up your mind. Pick one of the answers. Okay, let's see how many people I'm gonna see who are falling for the trap. All right, so those seem like the final answers. I don't see any other answers or anybody changing their answers. So, let me see. Natural Wonders says C, Brian says B, Sandra says C, Shan says B, and then she said curdling. Miguel says A, agglutination. Miguel has settled with B. The correct answer is curdling. Oh, father. The correct answer is C. So you know Jodian gets that point, right? Yeah. Guys, you can't listen to me, you have to stick with what you know. Correct answer is curdling. Now, you can say the proteins agglutinate or they coagulate because technically they do, but why I added separation of milk, then definitely you would say curdling. If you're talking about milk specifically. Next question. What is pasteurization and what is the purpose of it in yogurt making? And I need a proper answer, as you know, for you to get 3 points. You have to tell me what it is, and what is the purpose of it in yogurt making. Tell me what it is and the purpose it serves in yogurt making. Mikhail says it is heating. So you're telling me if I put some water on the stove and heat it, I am pasteurizing the water? Heating to denature whey proteins. Heating of milk to destroy bacteria and other microorganisms that may compete with the yogurt bacteria. Pasteurization is a process of heating milk to kill the pathogen that can spoil milk. See how me say purpose in yogurt making? Any other answers? Any other answers? Or will this be all? Alright, so Andre gets those 3 points because his explanation is most accurate to say it is the heating of milk, one, not just heating anything. Because if I boil some water, that is not pasteurization. Heating of milk, and what it does is to destroy bacteria and other microorganisms that may compete with the yogurt bacteria, because I said specifically what is its purpose in yogurt making. You don't want to have microorganisms competing with um, the culture or with the starter culture that you are adding to the yogurt. And they might compete with it and kill them. And then your yogurt just come out right. So Sandra gets those 3 points. We're going to move to the next question. And that question says, at what temperature is milk usually pasteurized for yogurt making? Is it 180.5 degrees Fahrenheit? Is it 185 degrees Fahrenheit? Is it 181 degrees Fahrenheit? Is it 185.5 degrees Fahrenheit? At what temperature is milk usually pasteurized for yogurt making? Let me see the answers. Show me the answers. Let's see the answers. I am seeing a number of A's and one B. Oh, are you going down? Oh, oh. Are those all the answers? The correct answer, my dears, is B. It is 1.185.0. And nobody got that point. People, no serious. What me do with it, sister? Mikhail, what is wrong with you, please? No, you can't, but I get it again. Funny, 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 funny. You can't, but I get it again. I guess the point is gone because why did you change your answer? I can't even understand why. You can't get it again. We just have to move. And I didn't even realize because I just looked at something else and looked back. And I didn't even realize that nobody had the right answer. Well, the answer is B, is 185.0 degrees Fahrenheit, and I guess nobody gets that point. So we're going to move to the final question, I believe. And this is 5 points. So you must explain properly to me. How does fermentation result in the formation of yogurt? You have to explain this thing properly to me. It's 5 points in a people. You have to break it down. You have to be thorough. You have to explain it. Every week I give you guys more and more points. How does fermentation result in the formation of yogurt? I'm not even sure how much time I go over this. I go over it and over and over and over again. So we should know by now how to explain what's happening in fermentation that makes us go from milk to yogurt. Let's see the answers. We're going to say why the milk a turn pink, you know. We're going to say why the milk a turn pink. We realize that the cap. Right? You know, on the people not easy. I tell you, I'm giving you 5 qualified points for a proper explanation of what happens in fermentation going from milk to yogurt. And you give me one sentence with 7 words. A 7 or 8 words. 7, 8 words. Bacteria convert the milk sugar into lactic acid. Mikhail says fermentation results in the formation of yogurt because ellipses. Increasing acidity resulting in curdling. That is a very big jump right there. So over a lot of things. The yogurt culture is placed in the cool milk. It converts sugar to lactic acid that lowers the pH, and the high pH protonate the protein. Okay. All right, these answers are not 5.1. I'm going to give you guys time to submit your script. I'm gonna give you some time to submit your script. Waiting on the scripts. Hmm? Juicy? 4. Listen, and all right. So let me see the rest of the answers. The protonated, the protonated, I'm gonna ask you the name protonated. The protonated protein is denatured. The denatured protein reassemble by interacting with other protein. This interaction results in a network of molecules that gives that sound like a Google answer. Alright, Cheyenne says it drops below. Cheyenne, I'm not sure what Cheyenne referring to when she said it. It drops the pH. I'm guessing fermentation is the it. It drops the pH below 5, so micelles of casein will form and lose its tertiary structure. The bacteria converts milk. Okay, that was Sharon's answer. Sorry. Jodian's answer now. I'm guessing this is a continuation. Bacteria converts milk into lactic acid, which increases the acidity. The casein proteins reassemble by interacting with other proteins, resulting in molecules. That sounds like some Googled answers. Or you just copied what I had, which is not necessarily going to get you the points. All right, so here what? Since people don't really know how to say things in their own words, I'm going to give, let me see. I am going to give Ciandre 3 points, and I'm going to give Shan 1 and Jody 1. Because the first part of Ciandre's answer, I can tell he was writing from his head, and then he just went all Google. He just went all Google on me. Hi. So Ciandre gets 3 points, and Jodian gets 1, and Cheyenne gets 1. That would be this. 1 for effort. We don't give points for effort. You have to give me. You have to give me something to get points for. That's I can't just be giving away points like that. That's crazy. Alright, so the total of points for today, which may or may not be accurate, I feel like I have to watch over the recording because I am pretty sure I had more 3-point or 2-point questions, but I will give you the sum that I have now. Nevertheless, and then when I check it over, I correct everything or make sure everything correct. So 6, 8, 10, 7, 4, 4, 1. So the total that I have for today, Ciandre has 11 points, Shan has 4, Jodian has 4, and Miguel has 2 points. So again, Ciandre has 11, Shan has 4, Jodian has 4, and Miguel has 1. By the way, Jodian, what's your last name? Your last name, so I can write it down. I don't recall seeing your name. But all in all, that's it for today, folks. For next month, Maglashon. Okay, look in the description of the video. You see a membership form. You can fill it out. Maglashon. It's in the description of all the videos. I think you have to click show more and you will see the link for it. So click on that link, the link that says registration. I never see your name before, and that's why I asked, Jody, and I just don't recall seeing a Jody. But you can fill this out again. So that's it for today, guys. In terms of the final product, we have to incubate it for about 5 to 6 hours, and then we add the flavoring and stuff. So after that, it can just stay on the fridge, and you guys can probably see it next week. For next month, our theme is gonna be biochemistry. So we'll see what we will be doing experiment wise for next month. But we should be having more Teams meetings and maybe at home experiments for next month. We have 5 Thursdays in March. That's 5 meetings. So yeah, that's it for today's meetings. I will see you guys next Thursday um, at 2:30 p.m. Bye, everybody.